Machine learning is dead. That's what influencers are telling you. Let's try to see with facts and figures how right they are. Welcome to Unfold Data Science. My name is Aman and I am a data scientist. Please ensure you watch this video till end to get a wider perspective of how things work on the ground. Like many of you, I am also interested in this topic a lot. Is traditional machine learning dead in the age of Gen AI? So I went to the internet, did lot of research, and in this presentation I bring to you my facts and findings. So what we will be trying to understand is LLMs can code, write and reason, so is machine learning obsolete? Or is machine learning quietly running the world behind this hype? We will try to find out with the help of data. In the end, I am going to show you a very nice pyramid that will give you a very good perspective of how the technology landscape is working on the ground, what it takes to build a data driven project. Please be with me towards end of this video, guys. You are going to learn lot of things. Okay, first of all, how we got here. So we got here in three phases. Phase 1 is traditional machine learning era. So the world of linear logistic regression, decision trees, random forest, SVM, gradient boost, etc. All of us know this era. It was the era when people were talking machine learning, doing machine learning, etc. And then came the era of deep learning, right? So neural networks, CNNs, RNNs, etc. And then comes the big guy transformers. And with the advancement in transformers, right, we saw GPT models, we saw generative capabilities, transform text and creative tasks. Many things started happening, and what we know today as generative AI started coming. But here is the reality. Most businesses data is still tabular and structured, where traditional ML excels. I'm going to show you some use cases, some facts and figures now. Let's see some more things. AI is mainstream, not just LLM. So outside of LLM also, there is a lot of AI. And that AI is shown in this diagram. If you see, right, companies currently using AI and actively exploring AI, if you sum these two, it will come close to 80%. So as you can see here, over 82% of companies are engaged with AI, signifying its mainstream adoption. So basically companies are adopting AI or trying to adopt AI. But important thing here is this AI goes beyond LLMs and chatbots, encompassing vital applications like predictive analytics, recommendation system and fraud detection, primarily driven by traditional machine learning. And this is, every time I show you some facts and figures, guys, I'll give you some source which you can go and check. You can check this source, but understand that 82% of companies are using AI or exploring AI, and many of those use cases is not LLM. That is your first knowledge source. Second thing is hiring signals. So ML is very much alive. How? Let's see some figures. Market growth of machine learning in 2025, 113.1 billion US dollars, projected to be by 2030. You see the growth here almost 5 times. So if somebody tells you that there is less hiring happening in ML machine learning, don't listen to that guy. Employment boom, you can see the numbers, how much is added last year. And if you see the chart here, this is again a report by 365 data science that was published in April 24 2025, right? ML job posting prioritize code and machine learning skills plus machine learning operations plus cloud platforms. These are the things that is still in demand over exotic algorithms, and these are done from analysis of 1157 posting. So this is like a report. You can read more about this on googling this, but the key point here is hiring signals also is telling you that machine learning is not going anywhere. The demand is there in terms of new requirements. Inference got cheaper with time. Very critical point which I am touching now. The inference of the model got cheaper with time. But what else happened? The cost revolution in AI inference has been nothing short of spectacular. I agree. Making powerful language model accessible to businesses of all sizes. Yes, I agree. And this is the chart supporting it. If you see, right, cost of inference per million tokens for GPT 3.5 have come down by almost 280 times. See, cost per million tokens dropped 280 times for GPT 3.5 level performance. Hardware cost decreased 30% annually, while energy efficiency improves 40%. So these are good things. But you need to understand something very clearly here, guys. Using LLM is not only inference. Okay, using LLM is not only inference. Hence, cheap tokens don't necessarily mean cheap systems. Key point to understand here. When you factor in infra, latency, and reliability requirements. So, this again comes from this report, you can read about it. But remember, inference getting cheaper does not mean LLMs becoming accessible for day to day work. Now, training costs are exploding like crazy. So, as I am saying here, inference got cheaper. The frontier of AI model training tells a different story. If you see here, right, 3x annual growth training cost, 2 to 3 times per year since 2016. Training cost is increasing. By 2017, the projection is largest training runs expected to exceed $1 billion, right? And then current reality is almost 100 million is going on in a GPT-4 kind of models. Now we are in GPT-5 era, but GPT-4 kind of model also crossing this. So what is the bottom line here? Bottom line is executive report training runs exceeding 100 million with $1 billion run already underway. This exponential cost curve explains why deep learning and LLMs aren't the default solution for every tabular data problem in business. You can't do this. Why? You can't build models. You can't, there is no out of shelf solution you can take and use. And that too when you have tabular data in your business scenarios. This you can read more about it at this place, right? Why traditional machine learning still wins? The right tool for right job remains the fundamental principle of effective data science and engineering. So why traditional machine learning is still relevant or useful? First is cost effective. The lower computational cost for small to medium data set and structured tabular data. Training and inference require minimal infrastructure investment, right? Then interpretable, very important. When you go into sensitive business domains like medical domain or insurance domain or anything to do with finance, right, you need interpretability, you can't like skip it. Okay, and then fast deployment you can do. You don't want something which is heavy to deploy, training cycle is very big, maintenance is very big, retraining is very big. You want to avoid those things, right? So faster deployment. These three things, right, give you a edge of traditional machine learning over generative AI or new age what we call as LLMs. Let's see some of the case studies, guys. This will again open up your brains in what is happening and why these traditional machine learning are winning. So if it's a financial decision making scenario, right, one traditional approach is logistic regression is gold standard for credit scoring due to its interpretation, compliance, and robustness. This is again a research highlighted tree-based ML with oversampling outperforms logistic regression, maintaining explainability via SHAP. So I have video on SHAP, you can watch that. But the thing here is uh, basic models, right? Logistic regression is a basic model, tree-based model is a basic model, and this is outperforming. Basically, it's outperforming logistic regression, but it is giving you SHAP means explanation, and hence it wins in this kind of scenario. So data collection is your step, feature engineering is your another step, model training is your another step, and explanation is another step. So in these four steps, right, business is happy, what you are trying to achieve that is happening, so everybody is happy. You can read more about this research where through these four steps, right, a very nice model was created that was used for finance and credit scoring. Now let's see one more case study in healthcare risk prediction. So healthcare application demand highest standard for accuracy and interpretability, making traditional ML approaches essential. You can't skip interpretation. So let's take a large scale chest pen study utilizing comprehensive patient record. Then some feature engineering which is domain specific like SMOT and class balance. Then Bayesian optimization, this is again a traditional machine learning. And then SHAP explanation, modern interpretability for clinical decision support. So 2025 study published in Frontiers in Psychology showed that a full ML pipeline with light GBM achieved the best performance, right? While logistic regression remained valuable for transparency, SHAP explanation bridges the gap between accuracy and interpretability. So if you see here, all the techniques are traditional machine learning techniques and it is doing the job. And these are reliable reports, you can read more about it. So from these two case studies, you would have understood how machine learning is relevant for on the ground job, right? So let's debunk some of the myths now. What are some of the myths and facts? LLM beat everything. Reality. Frontier model costs, massive data requirements, latency issues, black box risks make them unsuitable for many regulated and cost sensitive applications. You can't use LLMs in regulated environments. ML jobs are dying. I showed you some things in the beginning. Same things I'm writing here, how much it grew. And then board hiring signals show a sustained demand across industries and skill levels. And everyone is using Gen AI is one more myth that you should be aware of. Many firms still exploring AI adoption, implementation remains uneven, with significant regional gaps like UK lagging US by 30% point. So it's not like everybody is using generative AI. These myths persist because they oversimplify a complex technology landscape where different tools excel in different contexts. This is the key for this video, guys. Different tools excel in different contexts. And I'm going to show you one pyramid now, which you will love it basically. The technology stack reality. This is my favorite slide of this whole presentation. And I have made it with lot of time, guys. So just understand this carefully. How the technology stack work on the ground. First, there will be data collection and storage. Okay, that is bottom of the pyramid. Then data and infrastructure will come. So you will have an infrastructure where you will have a data lake, where you will have a pipelines, where you will have things to run. Many things will come in data infrastructure. And then comes traditional machine learning, right? If you have data, if you have infra, then you can do traditional machine learning. And in number 2 you have deep learning, the lesser scope for deep learning. Why? Because traditional machine learning has more data to work on. Deep learning has less data to work on because more data is structured, more data is in proper format. In businesses I'm talking about, don't think about social media data, etc. I'm talking about real hard businesses. Data is sitting in rows and columns in tables, right? Lot of data traditional ML has to work on. Then comes deep learning, and if I go one more level up, right, then comes your LLM and agent. So in terms of what data you have to work on, plus what use cases you have to work on, plus what solves the problem on the ground, in all these three cases traditional ML is a larger player here. Then comes deep learning, then comes LLM and agents. So modern AI systems are built in layers, traditional ML forming the critical foundation. Each layer serves specific purpose and use cases, with the most sophisticated application often combining multiple approaches strategically rather than replacing one with another. So basically it will not replace one with another, but see what is needed where. That is the key thing here. And traditional ML is not dead. That is what is the conclusion from this entire slide. It's foundation of modern AI. So you have to do strategic tool selection, use LLM where they shine, generative AI, NLP, creative application, deploy ML where it wins on cost, speed and interpretability. Career advantage, fluency across both traditional ML and modern AI creates sustainable competitive moat in an evolving job market, of course. And then business impact, the most successful AI implementation combine the strengths of multiple approaches rather than betting everything on a single technology, right? So you don't have to leave traditional ML. You have to keep learning new things and keep improving your knowledge. And that is where you have to check the Udemy links below in the description of the video, where I teach data science from zero to hero, making everybody a data scientist no matter which background you come from. I cover all the topics, right from how to code in Python to what is machine learning to how to do projects to SQL to everything. English and Hindi both courses are there, so you can take those. And please go ahead, enroll those courses now. Let me know if you face any issues. There is a discount coupon available already. If you click on that link, you are directly going to get the discount. And don't leave learning either machine learning or generative AI. Both are needed, both have their own place. Okay, bottom line, traditional ML is not dead, neither the generative AI. So both should go parallel. Okay, see you all in the next video, guys. Wherever you are, stay safe and take care.